Hello and welcome to this session on breaking up monolithic websites with Azure. So if you've seen this channel before, there isn't a huge amount of content on it, but today we're going to be focusing on Azure and breaking up monolithic websites. We will get back to building some physical products in the very near future. Today's session is part of Azure Global. If you're not aware of Azure Global, it is a series of events that are running from the 5th to the 7th, and you can see all of them online at globalazure.net. So do go and check all of those out. Before we get started on the main part of the presentation, just want to introduce myself. If you're not aware of me, my name is John Kilmister, and I've been a software engineer for many years and currently a certified solutions architect. You can find me on Twitter at John Kilmister should you have any questions later, and I also have an Azure based blog at blueboxes.co.uk. What are we going to cover today? Well, we're going to have a look at the concept of a software monolith. What is it and how do we work with one? Then we're going to look at load balancers and routing. And through this we'll look at Azure Front Door and a number of other load balancer offerings inside Azure. And finally we'll look at a few additional Azure services that we can use to help us break up our software monolith. So let's start at the beginning. What is a monolith? Well, a monolith in its traditional sense is just a single massive block, be that of stone or metal like this example here in Utah. But when we're talking about software, what do we mean? Well, a software monolith, much like a physical monolith, is where everything is together. And in a software monolith, that means all layers of the application. They're all coded together, they're managed together, and more importantly, they're deployed together. This can be seen as a bad thing, but it's also a good thing. So when your team is small and your application is small and it doesn't have a huge amount of functionality, a monolith can be really beneficial. It means you can add features quickly. It means that everyone knows where everything is. You don't have to worry about spinning up additional infrastructure, additional processes for deployment, and various other activities that go on in a more complex system. However, at scale, monoliths can become a bottleneck, with large teams all contributing to the same code base that houses many features, and that gets deployed all in one large block. It can start to be a real challenge. And that's what we're going to talk about today, really, is how do we overcome this challenge in the context of a web application hosted in Azure. If we take the example of an e-commerce site, and we start off with a relatively small team of 3 people. And our e-commerce site is very straightforward. It has a checkout, it has a product page, and it has a home page. 3 simple features all bundled together into a software monolith. Now that is then deployed to Azure all in one go. Any new features, they get added to this same software solution and they get deployed in one go. But as time goes on, the product managers, product owners are getting frustrated that things aren't being delivered quick enough. And there's only 3 people, there's only so much they can expect. So we add in 3 additional developers, and they're all contributing to this same monolithic application. We're squeezing more features in, and this monolithic application is getting bigger and bigger. But it is still one block of software, and it has to be deployed as one block. So time goes on, and we add more engineers, and we get more congestion and more features, but we're still deploying everything in one block. And this is where we start to see some of the challenges with using a monolith at scale. Some of the other challenges are that you end up with an unmanageable code base. It starts to get very hard to find anything in this code base. You don't know where to look, and especially if you start to work in a new area, it's not necessarily organized in the best way. We have a lack of ownership. Because everything's together, you can't isolate out parts of the system for individual teams or groups of people to own. We have something called a high cognitive load, and that's the concept that everything you need to know in order to perform your job or the task that you're doing. And when you've got a large complex monolith that isn't compartmentalized, you have to understand a lot of different moving parts just to then add in one extra thing and make sure that you're not breaking everything. From an infrastructure side of things, you end up with all or nothing scalability. Because all of your code lives together in one big block, you then are deploying it in one big block, and that means it needs to scale as one big block. So if you're back in this e-commerce world and you run a promotion on one product, you have to scale the entire application. That includes the homepage, the checkout, and all of the other content. Instead, you'd ideally be breaking this up so you can scale just the product pages, or just your promotion landing page, or just the bit that you need. So that's going to save you money, but it's also going to be easier to manage. And then we have deploy congestion. When we are deploying everything as one large block, every feature that gets developed has one or two options. You either choose to deploy one feature at a time, and if you do that, you then have a queue of people waiting for their feature to go out. And as the team gets bigger, that just is no longer scalable. There are only so many hours in the day. Or you start bundling features together and shipping a release once every X number of days. Problem with this approach is that if there's a problem with one of those features, it can be hard to roll back, hard to identify the problem. You have to roll back the entire solution. So deploy congestion can really start to be a headache for larger teams when you're all working on the same code base. And all of this kind of comes together, and I think this tweet that I saw some time ago really emphasizes that we've got a large code base, our monolith. You get the brain overflow, so the cognitive load. No one person can know everything, and it gets to the point where the software is so big it doesn't fit into one person's head. Then you get silos where you get experts on parts of the system and on other parts of the system, but they all overlap and all kind of tied together. And then things go wrong. You get failed deployments which lead to Gantt charts, and development slows down and people get frustrated. Your customers leave because things aren't delivered or they keep breaking. And then you have engineers that leave, and you can't hire good engineers to work on this thing. So we end up with this downward spiral. But it's not inevitable. So let's look at how we can overcome these challenges by breaking up our monolith using Azure. Well, to break it up, we have a three-part solution. It would be good just to talk about the infrastructure, just about Azure, but we need to think bigger than that. This is a software product we're shipping, and therefore we need to talk about the software element of it. But the foundation of all of this is people and team. If we don't look at our organization, we're going to really struggle to break up the software. So we need a three-part solution. So let's look at each in turn now, spending a little bit of time on the first two, people, team and software, before diving further into the Azure infrastructure and the options that we have. So people and team. There's this concept called Conway's law, and the idea is that organizations design systems that mirror their communication structure. And this is really important when we're thinking about a monolith. A monolith will naturally be built if you have a single team. An organisation that puts all its engineers together in one block will build a system, even if it's made smaller components, that are effectively a monolith. When you organise the teams in a way in which they can all be autonomous, they can own individual things, and they will have a drive to break things into smaller blocks that they own, you'll in turn end up with software that ends up in smaller blocks and is easier to manage. So if you try and break your monolith up, but you keep your organisation as one sort of team of people that just kind of work on all features, but they're all still part of one team, you'll find yourself in a situation where you can never successfully break apart that monolith. Now, the people are important. This isn't the focus of this presentation though. We're here today to talk about Azure and front door and those bits and pieces. If you are interested more in this area, I can recommend the Team Topologies book by Matthew Skelton and Manuel Paris, where they talk about the 4 fundamental team types which can help drive this reorganization. The other book that I'd recommend is Accelerate, which talks about how we can build high-scaling, high-performing teams, particularly using metrics and numbers to evaluate the challenges and the solutions. So, 2 really good books if you want to learn more about that. So talk briefly about the people and team. Let's now talk about the software. So should we just start again? We've got this monolithic application and we've decided that this isn't what we want. It's causing us all these challenges. Now, a lot of software engineers will try and persuade or come up with a design that encompasses just tearing the whole thing down and building something new. But it's hard. This monolith probably grew up over 5, 10 or even more years. To rewrite everything from the ground up is going to mean a lot of disruption. We're going to have to stop any new features. We're going to have to put them all on hold. And then we're going to spend a pretty long time working out what the current application does and then re-implementing it all. And it could take years to achieve this. If you think it took 10 years to get your monolith, how long is it going to take to rewrite it in its entirety? And while you might get initial buy-in, or you might decide to spin off another team to work on this rewrite, it can be a real challenge to sustain it and make sure that it is successful all the way through. So what we really want to do is, much like this cake that might seem like a good idea to eat it all at once, but really you want to take it one slice at a time to make it manageable. That's exactly how we want to tackle breaking up our monolith. We want to break it up one slice at a time. We can do this over a long period, and sometimes we might go faster and sometimes we might go slower. And that really leads us on to the final part, which is infrastructure, and where we're going to focus the remainder of this talk. And it's through the infrastructure that we can enable separating out the software and rewriting the monolith bit by bit without affecting the customer experience. Before we dive into Azure, we're going to talk about some just general theory about routing and load balancers and how this can help us break up the monolith. So we've got 2 primary types of load balancers that work in 2 slightly different ways. The first type of load balancer is called a layer 4 load balancer, and what this is doing is it's taking the packets of data that come over the network and spreading them amongst a number of servers. In this example here, the user is accessing a single website, and we're using a layer 4 load balancer to share traffic to 3 different databases. Now, these types of load balancers can only really route in modes such as round robin, so going to each server in turn, or lower usage. What they can't do is make any decisions about routing based on the data. They're only interested in the individual packets. And that's where a layer 7 load balancer comes in. So in this second example, the user hits our entry point, which is a layer 7 load balancer. That can actually look inside and inspect the request that's coming in and route the traffic based on that. So it might be based on the source IP address. It might be based on a query string or a URL or a HTTP header. Actually anything that comes as part of that request it can use as in the decision to split the traffic. But we're using this alongside our layer 4 load balancer. So one isn't necessarily a replacement for other, they just have different purposes. We can also see load balancers as either internal or public. So here we can see our load balancer between our databases as an internal load balancer, and we can see our layer 7 load balancer in this case as a public load balancer because it's got an external facing IP address. Now, layer 4 and layer 7 load balancers could be both internal or external. It's not a condition of the load balancer type, but it is worth noting that some are internal and some are public. So how can this help us break up our application? Well, let's go back to our monolith now. So our user comes in on our domain name and hits the web server. And that web server is hosting our monolith. It has the front end, it has the back end, it's got the user interface, the API, the website, everything all as one block, and it hits the database. And we want to start breaking this up. Now we can break this up with microservices, a relatively common practice where we can create new components based around different parts of our application. So in this case we've got a product API, a shopping cart API, a checkout API. And we can do this quite seamlessly because the user is still coming in on their website domain, it's hitting the front end, and then the front end is deciding which back-end service to use. So the customer using the website has seen no change to the website. All the pages are there the same. And we can start to get some of the benefits by doing this. So the product API can be owned by an individual team. But the challenge is the front end still needs to be modified for most features. And the front end is still a monolith. And this could be quite large with thousands and thousands of pages. So how do we go and break the front end up? Well, if we take the same approach and we just break it up like this, we need to be able to get to each part of the site. And we could use subdomains, but subdomains are then going to probably break our existing SEO. We're going to have to do URL rewrites. It's also confusing for the customer and their experience. We want to make this as seamless as it can be. And this is where our layer 7 load balancer can come in. So the user is hitting our layer 7 load balancer now, and based on the URL we can then actually behind the scenes redirect them to one of the new front ends, and then that gets returned to them, and they don't know any different. It all looks exactly the same. It looks like one seamless website. We don't have to do this all in one go. We can break it up and do it in smaller chunks, something that we'll look at a bit more when we look at the Azure infrastructure. So just a quick review of the problems of a monolith and how this approach can solve those. The unmanageable code base should no longer be a problem, neither the high cognitive load, because we've broken everything up into smaller components that should be a lot smaller, neater, tidier, and you only have to learn that individual component. We shouldn't have the deploy congestion either, because we can deploy each of these components independently as and when needed. We can also scale them individually. And finally, we don't have the lack of ownership because we can give each of those components to individual teams. That's the theory. Now what we're going to do is have a look at how we can implement this inside Azure. So Azure offer 4 different routing and load balancing options: Traffic Manager, Azure Load Balancer, Application Gateway, and Front Door. And it's one of those things that when you first approach this topic, it can be quite daunting to see these 4 different options and understand which one is the right choice for you. We're going to go through each of these in turn and see how they fit our use case of splitting up a monolithic, public-facing website. Our first option is Azure Traffic Manager. And Azure Traffic Manager isn't a load balancer, it is a DNS routing tool. So you point the user at Traffic Manager. Traffic Manager then decides which server to tell you about. It returns the IP of that server to the user, and that user then navigates to that. Because it's all working at the DNS level, you get priority or weighted options for routing. You also get performance, although you do need to put a little bit of extra code in your website, and you get geographic. But you can't look inside any of the requests in the way that you could with a layer 7 load balancer. So it's a really useful tool if you want to split things between 2 different Azure regions. However, in our case where we want to split an application up based on its URL, it's not appropriate on its own. The next one is Azure Load Balancer. Now Azure Load Balancer works at the layer 4, so it's going to be working with the packets, so TCP and UDP protocols. It also lives inside a single Azure region. Because it's layer 4, its routing is limited to hash-based or source IP affinity, which just means that if someone's been to that server before, it will stick to it. The third option is Azure Application Gateway, and this is the first layer 7 load balancer we're going to be looking at. Because it's working at the layer 7, it's actually looking inside our packets of our data at the request that is coming in. It's working with HTTP and HTTPS. The Azure Application Gateway also exists inside a region, much like the Azure Load Balancer. So if you're looking for a geo-redundant solution, you need to pair it with another technology such as Traffic Manager. So Traffic Manager could go between regions, and then inside the regions you could use a layer 7 load balancer. Because we are looking inside at the actual requests, we've got many more routing options. We've got URL, we've got latency, and we've also got weighted and session and a couple of other options as well. The fourth option is Azure Front Door. This is also a layer 7 load balancer, so again working with HTTP and HTTPS, and we have all the same routing options, plus actually a few more. However, this time it is global, so it's going to sit outside an Azure region, making it highly redundant. It also offers additional features which we'll look at in a bit more detail later. So just to recap, we looked through Traffic Manager, which is global but isn't layer 7, so it's not going to work in this particular use case. We looked at the Azure Load Balancer, which is working at layer 4, so it can't look inside the individual requests, so isn't going to work for us here. Application Gateway can split traffic based on the URL, but it isn't global, so it would work paired with Traffic Manager. However, Azure Front Door ticks all of these boxes. It works at layer 7, so we can route based on the URL, and it's also global. So if we take Azure Front Door, how do we go about actually implementing it? We're going to start by looking at the theory and look at how we'll do the routing. Then we'll actually take a look at the Azure portal itself and look at the individual screens. So when you initially set it up, what you'd probably do is you would put your domain on Azure Front Door, and that is what people are going to be hitting. The traffic will travel through Azure Front Door, and we'll just set up a single route that says all traffic, take them to our existing monolithic website. And that's what you do on day 1. And that sets the foundation for being able to break out different parts of your application. We might take a simple part of the application, such as the blog. Doesn't change very much, but it might get a lot of traffic. And we can take anything that goes to /blog and redirect that to be serving it, in this case, from a storage account. So this way we can take just parts of our website based on the URL and serve them up to the user, but the URLs have not changed for that user, and to them it looks like one seamless website. And over time we can break out more parts, and we can use different technologies for this. So Azure Static Web Apps, which is probably preferred over storage accounts. And we can continue to break it out. Maybe our shopping cart is more complex, so we decide that we want to use an app service plan, an Azure web app. And then we break out our checkout and put that in a different set of Azure web apps, all that can be independently scaled, with the ultimate aim of removing our monolithic website. That then allows us to have completely independent parts of our website that can independently scale. And as we want to onboard new parts of our website and new functionality, we can add them in with new routes. And we can also allocate those out to different teams with different ownership. So that's the theory about what we want to do with Azure Front Door and how it's going to solve our problem. Let's have a look now at the Azure portal. Let's look at the features of Front Door and also some of the screens and how we'd go about configuring it. Front Door comes in 3 SKUs. There's Front Door Classic, as it's now known, Front Door Standard and Front Door Premium. We won't talk too much about Front Door Classic. It is there should you have any existing Front Door instances, and you can still technically, for now, create new Classic Front Doors. However, you should really be looking at the Standard or Premium SKUs. Front Door gives you lots of features. We talked about the layer 7 load balancing, but to actually talk at a more feature layer, we get URL rewriting, we get DDoS protection, we get forwarding and redirects, health probes, so we're not sending traffic to web pages, to servers that can't serve that. We obviously get ARM Bicep and Terraform support. We get built-in CDNs and compression. Because it's having to work on the requests that come in, it has SSL offload as well. If we go with the premium SKU, you also get the additional features that are highlighted in blue here. So we can secure the origins with private links, so these are the servers behind. We also get additional web application firewall and bot protection and integration with threat protection. So as you can see, Azure Front Door is a fully featured layer 7 load balancer. How do you go about creating one of these? Well, inside the portal you can just search for Azure Front Door, and from there we can click Create. The first screen that you're shown is a setting screen to choose which of the offerings that you want. We can select Azure Front Door, but we can also, to the right of that, explore the other offerings. Many of the features of Azure Front Door can actually be purchased individually. So, for example, the web application firewall can be bought individually, or the CDN, or various other bits and pieces. So they are available under the Explore Other Offerings. You'll also find the Classic SKU under there if you really need that. On the next line down, we have Quick Create and Custom Create. And these are just 2 different approaches. What we're going to look at today is more around the Custom Create. So when we're setting up our front door, we initially get an endpoint, a URL that's that ends in .azurefd.net. You can put your own domain on that later, and then and configure those bits and pieces. But the first thing we need to do when setting it up is add a default route. So this is the route that's going to all traffic is going to go to. So we have to give this route a name so we can identify it. We've got the endpoint, and you can add in a domain at this point, or we can leave that to later. The patterns to match. This is the important part about what URL patterns do we want to be pushing to our origins, to our set of servers. So the first one we add, we're just going to go and use the default of / star, and that just means all traffic is going to be sent to this group of servers. The next thing to configure is the origin group. Now, an origin group is a group of servers that serve that content. So it can be one or more servers. So in our case, we have our monolith application that we just want to put all traffic to. So we click to add a new origin group. And our origin group, we first have to give it a name. The name is just for identification purposes. It's never displayed externally. We then need to add in our origins. And when we say origins, we're talking about where we're going to route the traffic to. Now, this can be an Azure static web app. It could be app service plan. It could be a Kubernetes cluster. It could just be another URL or a CDN. You've got a lot of flexibility. So when we click Add Origin, we're then taken to the Add Origin screen. And this is where we fill in the details about the origin type. Here I've selected static web app, the host name that will be received, and any host headers that need to be present. We can also specify the HTTP port and HTTPS ports as well. Now, we might add multiple origins to the group, and that's where weight and priority come in. You can also disable this particular server or origin if you want to. And once it's added, it gets added to the list. And we can add multiple in. So for a given route, we can add multiple origins and it will load balance between those. If you need session affinity, you can also check that. So if a user goes to ends up on one of those multiple servers, it will stick to it for that route. The final box you see at the bottom is around health probes. So we can, if we want, check those origins in this origin group to make sure they're available before we actually send traffic to them. It's really useful. So if you have a server die, you're not sending traffic to it. One thing to note, however, is as your front door is global, that endpoint, that health probe, will be hit a lot of times from all around the world. So you don't want too much going on inside that health probe endpoint because it is going to get a lot of traffic. So once we're happy with the origin group, we can then return to our adding the route and select it from the drop down. So we now have our primary site. Right at the bottom of adding a route, you get the option to add rules. Now, rules give us an extra layer that sits on top of these routes. So we're currently filtering based on URL, based on a URL pattern. And we're saying anything that matches that URL pattern, redirect it to that origin group. With a route rule set, we can actually add in additional conditions. So we could say, if it comes from a mobile web browser, then append a query string. Or if it is coming from a particular country, redirect them to a different set of servers, a different origin group. It's got lots and lots of flexibility. It is completely optional. You don't have to have a rule set applied to a route. However, if you do want, you can configure it and it gives you that extra flexibility. So we can see here an example where we're taking all USA visitors. So if the incoming request has a matching address that matches a USA IP address, then in this case we're going to override the origin group and supply a new one. And this can be really good if you want to test internally. For example, you could say if the address comes from a particular IP range, then redirect them to a different origin group. So if you want to start previewing features and things like that. Or if you want to take everyone outside your country to a landing page to ask them to pick a country to be navigated to, you can do things like that. So it gives lots and lots of flexibility. So that's how we configure it. We set up routes that have origins, and those origins are actually origin sets that are made up of multiple origins, and then on top of that we can apply additional rules. And we just go back through that multiple times for each of the routes that we want to configure. So that's Azure Front Door conceptually, and having a little bit look at the portal. Sorry. As it is quite a feature-rich product, and there's lots of good content on Microsoft Learn to take you further with it. But before we finish today, I just wanted to talk about some additional Azure services that can help you break up monolithic applications. One of the challenges when breaking up our applications is shared configuration. We have now two separate applications, two separate parts of the website that we're showing to the user as a single website. But in order to show it as a single website, we probably do need to share some configuration. That configuration might be some brand settings such as colors or words, or it might be something like an App Insights key or a shared database connection string. So how do we overcome that? Well, we can use Azure App Configuration, which is a key value store that can be centrally hosted and accessed by multiple applications. Depending on the applications, it can even update the configuration in real time. If you have secrets, such as a shared database connection string, which you might have temporarily until you phase it out, we can actually use Azure Key Vault alongside Azure App Configuration. And when someone requests something that is a secret, it goes off to Key Vault and then feeds it back through the Azure App Configuration seamlessly, yet stored in a secure way. One of the other challenges that you might have is Authentication and Authorisation. This is helped by the fact that you're all working under the same, all these websites are all working under the same domain. However, it is still a challenge. You need to make sure that you don't get the customer to log in multiple times depending what part of the website they're on, because to them it still is all one website. There are multiple options around this, lots of third-party providers, but one option is Azure AD Enterprise Applications, which allow you to log in once and then you can use that token across all of your different applications. The final challenge I want to talk about is shared software components. Now, sharing configuration is one thing, but sometimes you need to share larger blocks of code. For example, you might want to share the same header and footer on your website. Even though they're different applications, they all need to have that same header and footer. So you can bundle that up into a software package. And Azure DevOps gives you the ability to host those, be that a NuGet package for C# or .NET more broadly, an NPM package, Maven for Java, or a Python library. And this can be really helpful when you break your application up to still have some reusable shared components. So just a recap on the things that we've talked about today. We've talked about what a software monolith is. Effectively, everything in the application is all together in one block. We talk about how that's not always a bad thing. Sometimes that can actually be beneficial. But you do start to get issues at scale with high cognitive load, deploy congestion, lack of ownership, all or nothing scalability. We briefly talked about the three-part solution, the fact that it takes people and teams to help change the code, and in turn the infrastructure can support that. We then looked at how we can use infrastructure to support that split, looking at some of the challenges that we get and looking at the difference between a layer 4 and a layer 7 load balancer. Before going on to look at how Azure Front Door as a layer 7 load balancer can serve our needs. Finally, we just wrapped up with some other services such as Azure App Configuration, Key Vault, and Azure AD for Shared Auth. That brings us to the end. If you do want to learn more, as I mentioned before, you can go to the Team Topologies website, to learn more about the organisational changes that can help enable this. We can also look at the Microsoft Learn website, and the Microsoft Docs website has a really good guide with a flowchart on choosing the right load balancing solution. There's also an Azure Friday video on on Azure Front Door, a brief introduction to that. So thank you for listening to me. As I said before, you can find me on Twitter at John Kilmister. You can also find my website and blog at blueboxes.co.uk. And this has been part of the Global Azure event, so do check out their website, which I'll put a link in the description, for the rest of the sessions. If you have any questions, do feel free to drop something in the chat that I'll leave open for a few more minutes. Otherwise, find me on Twitter, and thank you.